We can start class at 7:05. By that time, remaining people may join. Okay, we can start the class. Let the remaining people can join later during the session. Yeah. Today we are going to discuss about myself, Harish Karnati. I'm the research scholar in that IIT Roorkee, PMRF scholar. Today we are going to discuss assignment 2, basic electrical circuits. Yeah, is it audible, right? Can you please comment? Is it audible? Yes, fine. Thank you. Okay, I can read the comments after the each question. I think it will be fine. At the end of each question, I will read the comments. Okay. If you have any doubts in the question, you can drop it in a comment box. Yeah. That assignment 2 basically on KVL and KCL. KVL and KCL. What is meant by KVL? KVL is the Kirchhoff voltage law, which stands for the algebraic sum of the voltages in any loop is equal to 0. That is, let us suppose this is one loop, right? It's having a voltage of, let us suppose, VA, VB, and VC, with the signatures of this is a plus, right? This plus minus, and this is plus minus, and this is plus minus. Consider the current direction in the clockwise direction. Current in the clockwise direction. What is the voltage at VA when you are seeing in the clockwise? That entering direction is this one, right? It is minus VA. What about VB? It is plus VB. What about VC? It is plus VC. So the total sum equal to 0. This is the KVL. The algebraic sum of the voltages in the any loop is equal to 0. That is Kirchhoff's voltage law. Coming to the KCL. KCL stands for the algebraic sum of the currents at any node is equal to 0. Consider this is as a node A. The node is nothing but it's a junction point, right? It's having multiple branches like this, and whatever the current directions, let us suppose this is entering, this is leaving, this is entering, this is entering. This is IA, IB, IC, and ID. Write the equations that entering current is negative. Consider that entering current with the negative sign. That is, IA is entering, so minus IA. IB is leaving, right? So plus IB. IC is entering towards A, right? That is, sorry. IC is entering towards the node, so this is minus IC. Then ID is entering towards the node, right? This is minus ID equal to 0. That is, the algebraic sum of the currents at any node is equal to 0. That is KCL. I hope these definitions are clear, right? KVL and KCL. There's no comments. I consider it is clear. I'm moving to the next one. That is entering into that assignment. First question. Determine the Ix in the circuit shown in the figure 1 using the nodal analysis. First, here it's giving determine the Ix using the nodal analysis. First, we have to consider how many nodes here. How many nodes in this circuit? This is a one node and this is a one node. There are number of nodes equal to 2. However, in these two nodes, this one is reference node, right? This is our reference and this is actual node. Let us suppose this is VA, A node. The voltage at the node A is VA. That VA is the potential at the node with the reference node. That is nothing but VA with the reference node. Is it clear? So what is the nodal analysis? Nodal analysis is basically a KCL, Kirchhoff's current law. So we have to write the current equations, sir. Current equations, that too we have to consider leaving currents. So what is the current leaving from this point to this point? Here we have a voltage of VA and here we have voltage of 9 volts. Therefore, let us suppose this I1. I1 equal to VA minus 9 volts by 1 kilo ohm, right? That is, the current flowing from this point to this point is potential difference across the resistance. First we will write the equations. Yeah. Yeah, this current is I1 we considered, and this current we already given Ix, and this current we already, this is considered I2. According to that KCL, what is the KCL at node A? That is I1 plus I2 plus Ix equal to 0, right? Why? Because all are leaving currents. What is the I1 here? I1 equal to the voltage at this node A, that is VA, minus at the voltage at this point is, yeah, one more. Voltage at this point, that source is 9 volts by potential difference resistance from the Ohm's law, right? I1 equal to VA minus 9 volt by 1 kilo ohm, right? And what is the IA, I2? I2 equal to similarly VA, and voltage at this point it is 6 volts by resistance, that is, sorry, 4 kilo ohm. And what about Ix? Ix equal to the reference node voltage is 0, right? So VA minus 0 by 2 kilo ohm. So from this equation, how can we write? That is VA minus 9 by 1 kilo ohm plus VA minus 6 by 4 kilo ohm plus Ix. VA minus 0 means VA. VA by 2K equal to 0. Right? This is our KCL equation at node A. But what's the LCM? It is 4K. What about this thing? 4 VA minus 4 in 4 9s, it's 36 plus VA minus 6 plus 2VA equal to 0, right? What about this 4VA minus 36 minus 36 is 42 plus VA plus 2VA equal to 0. Just 4K, it will goes that side and it will be, it is 0 into 4K, it will be 0. So 4VA plus VA, 5VA, 5VA plus 2VA, it is 7VA equal to 42. From this thing, VA equal to 42 by 7. What's this value? It is 6 volts, right? So VA equal to 6 volts. Then what is the Ix? Ix we already defined previously. Ix equal to VA by 2K. So Va equal to 6 volts by 2K. It is 2 threes are 3 milliamps, right? Why? Because it is 2 kilo ohm, right? So it is 3 milliamps. So the answer is the first one, 3 milliamps. I think this question is clear. We will go to the comments once. Is there any doubts in this question one? Is there any doubts in the question one? Uh, I didn't get any comments, so I thought it's clear. I'm moving to the next question. Is it fine? Can you please comment if you have any doubts, or so that it will be a response. Yeah, thank you. Thank you. It's clear. Okay, fine. We are moving to the next question. Yeah. The next question is, for the circuit in figure 2, obtain the V1 and V2. Okay. Where is the V1? V1 is this point. This is V1 and this is V2. Here, nothing. How many nodes are there? This is nothing but a just nodal analysis, that is KCL only. We have to apply KCL at node 1 V1, and we have to apply KCL at node 2 V2, and we have to solve both the equations. That will give that V1 and V2 values. So first we will consider that V1. I mean V1 node as compared to this is reference node. Okay, this V1 node, what is that? Let us suppose this is my I1, this is my I2, this is I3, this is I4. So KCL at V1 equal, that node V1 equal to I1 plus I2 plus I3 plus I4 equal to 0. Okay, this I1 equal to, here the at node 1 voltage is V1, and at reference the voltage is 0, and by the resistance, right, this is 10 ohm. That I1 equal to V1 minus 0 by 10 ohm. Similarly, I2 equal to V1 minus, this is also in between the reference and the node reference node and first node. So V1 minus 0 by 5 ohm, right? And I3 equal to, I3 is same as 6 amps, right? Why? Because this I3 is in this direction, and the current is, this current source direction is also in the same direction. So I3 equal to 6 amps. Sorry. Yeah. This I3 is also in 6 amps, and I4 equal to, I4 is, yeah, just a minute. Yeah, sorry, just a minute. We will move this thing to little bit this side. Yeah, this one is the I1 and I2, I3 and I4. I4 is the current flowing from the node V1 to node V2 through 2 ohm resistor. That I4 one can write this, the voltage at node V1 is V1, right? And the voltage at the V2 is node V2. We are just finding this I4 current by using the potential difference across this 2 ohm resistor. The potential difference across this 2 ohm resistor is, here we have a voltage of V1, here we have a voltage of V2. The potential difference across this 2 ohm is V1 minus V2, right? V1 minus V2. So the current is voltage difference between, sorry, across that particular resistor by resistance of that particular point, right? This is clear. So one can write with these all four equations. Yeah. These are our equation. So what is the our KVL equation? I1 plus I2 plus I3 plus I4. Similarly, this I1 is V1 minus 0 by 10 plus I2 is V1 minus 0 by 5 plus I3 is 6 amps plus I4 is V1 minus V2 by 2 equal to 0, right? What is the LCM? It is 10. LCM of these all factors. So V1 plus 5 means it is 5 twos are, so 2 V1 plus here is a number 1, so it is 60, fine, plus 5V1 minus 5V2 equal to 0. It's clear, right? So we can write this thing V1 plus, sorry, we can write one more time, V1 plus 2V1 plus 60 plus 5V1 minus 5V2 equal to 0, right? This term goes to the side and it will be 0, right? So V1 plus 2V1 it is 3V1 plus 5V1 it is 8V1 minus 5V2 equal to, this 60 goes to that side, it means minus 60. This is our equation 1. This is at node 1. I think up to this point it is clear. We will go to the next node, that is at V2. Again we have to consider, this is let us suppose IA, this is IB, this is IC, this is ID. What is the KCL says? This algebraic sum is 0. That is IA plus IB plus IC plus ID equal to 0. Now IA, what is the IA value? IA is the potential difference. Now this time we have to consider this potential as higher potential and this potential has lower potential. Why? Because we are assuming the IA in this direction from right to left. So at, at positive point, what is the voltage? This is at positive, yeah, someone is joined. Yeah. At positive point, the voltage is V2. At negative point, the voltage is V1 by 2, right? This is IA. What about IB? IB is, previously it was 6 amperes. Why? Because both are in same direction. IB is this direction and 6 amps is in opposite direction. So IB equal to minus 6 amps. Why? Because it is in opposite direction to our assumed direction. I think it's clear, IB. So coming to IC, IC equal to the current flowing through the 4 ohm resistor However, that 4 ohm resistor is connected between this node 2 and the reference node. This is reference node, right? Like this it is connected. So the voltage at this point is V2 and the reference node voltage is 0 volts. IC equal to V2 minus 0 by that resistance 4 ohm. It's clear, right? And ID equal to, we are considered the current towards downwards direction, that is like this we consider, but the current source direction is upwards direction. The both the currents are in opposite to each other. So id equal to, what will happen? Id equal to, it is opposite, right? Minus 3 amp. Okay, from the this KCL, how we can write IA, that is V2 minus V1 by 2 plus IB minus 6, right? Plus IC, that is V2 minus 0 by 4 plus ID equal to minus 3, right? Equal to 0. The LCM is 4, therefore 2V2 minus 2V1 minus 4 into 6, it is 60, sorry, 24 plus V2 minus 4 3s are 12 equal to 0, right? That is 2V2 minus 2V1 minus 24 minus 12, it is minus 36 plus V2 equal to 0. This 4 goes to that side. So this minus 2V1, okay, minus 2V1 plus 2V2 plus V2, it is 3V2 equal to minus 36 goes to that side, it is plus 36. This is our equation 2 at node 1. By solving these two equations, that is equation 1 is this one, 8V1 minus 5V2 equal to minus 60. 8V1 minus 5V2 equal to minus 60, and this equation minus 2V1 plus 3V2 equation 2, that is 36. By solving these two equations, we can multiply the second equation with 4, and what will happen? Minus 8V1 plus 4 3s are 12, 12V2 equal to 4 into 36. What's the value of 4 into 36? It is 144, right? This is equation 3. By adding this equation 1, so 8V1 minus 5V2 equal to minus 60. Add both and these two will be cancelled, and 12V2 minus 5V2, it is 7V2. 144 minus 60, that is 80. So V2 equal to, sorry, 84. It is 84. So V2 equal to 84 by 7 it is 12 volts, right? And what about the V1? Put this equation, we will move these equations little bit this side. Yeah, put this V2 value in equation 2, 2 or 1, whatever it may be, it's up to your case. So minus 2V1 plus 3 into V2 is 12, right? Equal to 36 minus 2V1 plus 36 equal to 36. So V1 equal to 0. So answer is V1 equal to 0 and V2 equal to 12 volts. That is V1 equal to 0 volts and V2 equal to 12 volts. This is option 1. Is this clear? Shall we move to that next problem? Okay, fine. We are moving to the next problem. Yeah. Next problem is find the currents I1 through I4 and the voltage V0 in the circuit in figure 3. Okay. Here, how many nodes are there? First, if in the question he didn't given anything like nodal analysis or uh, KVL or KCL, any method, particular method, then consider number of nodes and number of loops. First, find out the number of nodes and number of loops are. And how many loops in this given circuit? This is one loop, and 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 this is one loop. Total how many loops? Loops are 5. Okay. How many nodes here? This is and this is connected to, in between there is no element, right? So these, sorry, these two are one nodes and there is no element, right? And these two are one node and these are one node. So total this entire thing is one node. That is this one node only, and this is reference node. So nodes are one node apart from the reference node. So if you go through the KVL or mesh analysis, you have to write 5 equations for each loop and you have to solve 5 equations. If you go through that nodal analysis or KCL, you can solve this question with one equation. So based on these things, if in this question is not mentioned any method, so we can choose for this particular question, we can choose nodal analysis. So we are erasing these loop numbers. Okay. In the nodal analysis, it is from KCL, right? We already adopt to KCL, so that is consider this is, let us suppose, uh, IA, IB, IC, ID, IE, IF. What is our KCL? states it's a algebraic sum of the currents at particular node, that VA node is 0, right? That is IA plus IB plus IC plus ID plus IE plus IF equal to 0, right? This is our KCL at that VA node. Then find out IA, IB, IC, ID, I up to IF. First we will IA equal to, IA is from this direction to this direction, but the source direction of current is in opposite direction. So whatever this current direction we consider, that is exactly opposite to that source direction. So the source will be negative to our considered direction, that is minus 10 amperes, right? And IB equal to, IB is the current flowing through this point. So how can we find out this current? Here the potential difference across this 10 ohms by 10 ohm, right? How can you find out this potential difference across this 10 ohm? The 10 ohm top point is connected to this VA point, and 10 ohm bottom point is connected to reference point. So here the voltage is VA and here the voltage is 0. So the total potential difference is VA minus 0 by resistance, it is 10 ohm. So VA by 10 ohm. We can write like this. Similarly, IC equal to, yeah, summarizing like, yeah, same as IB, IC equal to the potential difference across this point and 20 ohm, right? Similarly, the potential difference is VA minus 0 by, here the potential remains same, potential difference remains same, but the resistance is, here it is 20 ohm, na? So VA minus 0 by 20 ohm, that is VA by 20 ohm. It's clear? Then ID equal to, similarly ID also remains the same. It is like the 30 ohm resistor connected between VA and reference node. So VA minus 0 by 30 ohm, that is VA by 30. And this IE, here we are coming to here, IE we consider this downward direction, that is leaving direction, and the source current, the 2 amps direction is also in the same direction as our reference. So that IE equal to same as that source current, that is 2 amperes. IE equal to 2 amperes. Then IF we consider like this, and IF is potential, similarly same as previous ones only. IF we consider this potential difference across these points and the resistance, that is 60 ohm, right? The potential difference across those points is, this is VA point and this is reference point, this is 0. So we can write IF like VA minus 0 by, that is 60 ohm, right? That is VA by 60 ohm. We can write like this now. So from the KVL, from the nodal equation, that is IA plus IB plus IC plus ID plus IE plus IF equal to 0, that we can write, yeah, one more, that we can write IA equal to minus 10 amps I'm not representing units. Okay, minus 10 plus VA by 10 plus VA by 20 plus VA by 30 plus 2 plus VA by 60 equal to 0, right? That is case nodal equation at the VA node. Yeah, we can copy this equation and paste it in next page. Copy. Yeah, this is our nodal equation. So what is that LCM? The LCM is, let us suppose consider 60 minus 10 into 60, it is 600 plus 6 VA plus 20, no? This is 3 VA plus 30 means this is 2 VA plus 2 into 60 means it is 120 plus VA equal to 0. We can put this 60 to this side, then it will be minus 600 plus 6 VA plus 3 VA plus 2 VA plus 120 plus VA equal to 0. Is clear? Just I sent that 60 towards that side. Then minus 600, sorry, minus 600 plus 120, we can send it to that side. That will gives plus 600 plus, sorry, minus 120, and these are 6 VA 3 VA 6 VA plus 3 VA, it is 9 VA plus 2 VA, it is 11 VA plus VA is 12 VA, right? I think it's clear, 12 VA. So VA equal to 600 minus 120. What is the value? 600 minus 120. It is 480 by 12. What is 480 by 12? It is 40 volts. This is the node voltage at this point is 40 volts. Coming to the question, what he asked the about I1, I4 and V0. I1 in the sense this is I1, yeah, this is I1 we represented with IB, right? That IB equal to VA by 10 we represented like this. That I1 equal to I1 we represented with IB. What is that IB? That is VA by 10. Here VA equal to 40 by 10 is 4 amperes. Okay. And coming to the I4, next one is I4. Find out I4. I4, where it is I4? This is I4 equal to current through the 60 ohms. We represented with IF. I4 we represented with IF. What we find out that IF equal to, we identified here IF equal to VA by 60, right? So we can represent IF equal to VA by 60, that is VA equal to 40 and by 60, 40 by 60, that equal to 0.667 amperes. Okay, IF equal to 0.666 amperes. And what else we have to find out? We have to find out V naught. V naught we already find out that V naught equal to minus 40 volts. So I1 equal to 4 amperes and I1 equal to 4 amperes and yeah, we will write our answers. I1 equal to 4 amperes and I4 we find out this is 0.667 amperes or 666.7 milliamperes. We can write like this, right? Then V naught equal to 40 volts. What's the option? That is option A. Okay. The, just simply I4 he returned in milliamperes. We got in amperes, that can be written in milliamperes, right? How this can be written in 666.67 milliamperes. Is it clear this question? Okay, shall we move to next question? Okay, we are moving to next question. No one has any comments. Okay, we are moving to the next question. This question is given the circuit and calculate the currents I1 through I4. So we will proceed same as previous question. That is here this we can consider one node. This is, let us suppose VA, and this we consider one more node, and this is VB. Okay, this is VA and this is VB. Similarly, same as previous question, previous form, we consider this one as I1 and this one as I2. Okay, here also represented with I1, 2, 3. Okay, we can do one thing, we will consider IA, IB, IC to avoid just confusion. IA, IB, and this is IC, and this is ID. Okay, similarly the KCL IA equal to IA plus IB plus IC plus ID equal to 0. What is the IA? IA is just opposite to 4 amps, right? That is minus 4 amps. Then IB equal to same as previous one. IB equal to the potential difference across this point. That is this point. At this point the voltage is VA, and at this point this is reference point, right? That is 0 volts. So I this can be written as IB equal to VA minus 0 by 5. That is VA by 5. Right? And IC equal to uh, here na, the potential at the voltage difference across this point, and by the resistance of this resistor, that is 10 ohm. The potential difference is Va minus 0 by 10 ohm equal to Va by 10, right? And what about ID? ID is the current which is opposite to this 2 ampere source. That means the ID is opposite to this 2 ampere current source, means that ID equal to minus 2 amperes, right? ID equal to minus 2 amperes. Okay. From this KCL, that is nodal equation at node A, how can we write this equation? That is minus 4 plus Va by 5 plus Va by 10 minus 2 equal to 0. What is the LCM in here? It is 10. This is minus 4 into 10. It is 40 plus 5 2s are so 2 Va plus Va minus 2 into 10, it is 20 equal to 0. We can send this 10 to this side, right? So that is minus 40 plus 2Va plus Va minus 20 equal to 0. This minus 40 minus 20, it is minus 60. You can send it to that side, it is plus 60, right? Then this 2Va plus Va, it is 3Va. So Va equal to 60 by 3, it is 20 volts. The voltage at the node A, that is this voltage equal to 20 volts. What he asked in the first question? First question is I1. Find out that I1. I1 is this one. I1 is, so just erasing this thing. This just to avoid the confusion, I erased this one. I1 in the question is same as IB in our assumed direction. This one, right? I1 and IB is same. IB equal to VA by 5. So I'm writing here just I1 equal to IB in our direction. That is VA by 5. That VA is 20 volts by 5. That is I1 equal to 20 by 5 means is 4 amperes. So I1 equal to 4 amperes. Okay. Next, we will apply the nodal analysis at node B. That node B is, we consider here as node B, right? This is VB. Okay, in previous case, we assumed that leaving direction of currents are IA, IB, IC, and ID. In this case, we consider the direction of currents as IX, IY, UVW. Just okay. IU, IV, IW, IX. Just to avoid confusion, I consider like this. So, okay. What is the KCL equation? It is IU plus IB plus IW plus IX equal to 0. This is the KCL equation at node 2, that is V at VB. So find out this IU, IV, IW and IX. IU equal to IU is this direction of current, and this direction of current is same as the 2 amperes source direction. So the IU is same as the 2 amperes, right? And IV equal to, IV is this the potential difference across this 10 ohm resistor and by this resistance, right? The potential difference is here, it is connected to VB node, that is VB, and here it is connected to reference node, that is 0 volts. The potential difference is VB minus 0 by resistance 10 ohm, that is VB by 10 ohm, right? Just drawing a line and I will return this side. And IW equal to same as previous. It is like here this point is connected to reference, sorry, our node 2, that is VB, and this point is connected to reference node, that is 0 volts. So IW equal to VB minus 0 by 5 ohm, that is VB by 5. Then what else? Ix. Sorry. Sorry. Yeah. Just a minute. Just a minute. Yeah, I think it's clear. Yeah. Hmm. Ix equal to Ix equal to the current flowing, the current in this direction, right? The current in this direction. However, the 5 amps current source is in opposite direction. So Ix equal to minus 5 amperes. So one can write that Kcl equation, IU equal to 2 amperes plus IV equal to VB by 10 plus IW equal to VB by 5 plus Ix equal to minus 5 equal to 0, right? What is this? Just a minute. Having some issue. Meanwhile, you can try that same thing. Yeah, yeah. It is that LCM is 10. Uh, uh, it's audible, right? Some comments. Your screen is not visible. I think now it is visible. My screen is visible. Yeah, thank you. Uh, the LCM is 10, right? So it is 2 into 10, it is 20 plus VB by it is VB plus here the 2, it is 2 VB, here it is minus 50 equal to 0. So it is we can send the 10 towards that side. So it is 20 plus VB plus 2 VB minus 50 equal to 0. So 20 minus 50, it is minus 30. You can send minus 30 to that side, it is 30. So VB plus 2 VB, it is 3 VB. So one can find VB equal to 30 by 3, it is 10 volts, right? That VB equal to, VB means the voltage at this point is, sorry, 10 volts, right? Yeah, this is 10 volts. What he asked, I4. I4 is the current flowing through this 5 ohm, right? Sorry, I4 is same as that IW. This one I4, this is same as our IW. Whatever IW, it is VB by 5. VB by 5 means that I4, where should I write? Yeah, I will write here. I4 equal to our IW, that is VB by 5. Our VB is 10 volts by 5. It is 2 amperes. So I4 equal to I4 equal to 2 amperes, and this I1 equal to how much we found out? I1 equal to 4 amperes. So the option is 4 amperes and 2 amperes, that is option B. Is this clear? Uh, is there any doubts in this? I think no comments. I'm moving to the next one. Yeah. Next one is obtain V naught. Where is V naught? At this point, the voltage across this 4K ohm. This problem you can find out through the nodal analysis. How many nodes here? One node. Here reference node this is. So number of nodes are 1. How many loops? Actually, this is more than a 1 hour. Parallelly you can try. You can try this problem. Yeah. Shall we go with the nodal analysis or mesh analysis? If we go through the mesh analysis, how many loops here? This is one loop and this is one loop. We have to find out two equations and we have to solve. If we go through nodal, it is one node. You can solve with one equation, right? First, we will solve with the nodal only. If it is, if you want to solve in with the mesh equations also, we can do. Yeah, same. Sorry for the disturbance. Yeah. Uh, you can try this question. Meanwhile, facing issue. Please try this question. You can. It's 8 7. You can try up to 8 12 or 8 15. You can drop your answers, and we can also solve after you will dropping 8:15. Chinna, it is 20 volts. Okay, we will solve. We will solve, no issues. Here it is the I1. Yeah. Here it is this I2. Here it is I3. What is the I1? I1 is, here it is voltage of, let us suppose, VA. VA. Okay, VA. That is VA. What is this voltage? Here it is. What is the current flowing through this one? That is our IR. Bigger one. It's better. What's going on? Sorry for the inconvenience. Again, it's take 2-3 seconds to share. Yeah. This is IA, this is IB, and this is IC. I'm directly writing these equations. This IA equal to the node voltage VA minus 30 by 2K. Then IB equal to VA minus 20 by 5K, and this IC equal to VA by 4K. The KVL equation is IA plus IB plus IC equal to 0, right? Sorry, that KCL equation. So VA minus 30 by 2K plus VA minus 20 by 5K plus VA by 4K equal to 0. The LCM is 20K, right? 20K LCM. So that is 20K means it is 10 times 10 VA minus 300 plus 5 4 right, 4 VA minus 80 plus VA LCM is sorry 4K, and this is 5 VA equal to 0. This 20K goes to that side, and it is, we can write one, yeah, you can copy this thing. Next page. So we can write, how can we write, 10 VA minus 300 plus 4 VA minus 80 plus 5 VA equal to 0. So this 10 VA plus 4 VA, it is 14 VA. 14 VA plus 5 VA, it is 19 VA. Is it clear? This 10 VA, 4 VA, 14 VA plus 5 VA, it is 19 VA. Then this is minus 300 and this is minus 80. It is we can write 380. We can send it to the that side. It is plus 380. Then VA equal to 380 by 19. It is 380 by 19 means it is 20 volts. The VA, the voltage at this point is 20 volts, uh, as corresponding to this point. That means the voltage at this point, that is VA, equal to 20 volts. What is the V naught? V naught is the voltage across this 4 kilo ohm. That is in between, only, no? This voltage is same as this VA. Why? Because this same point is connected to here, and this reference point same is connected to here. So V naught equal to 20 volts, right? So the option is B. Is it clear? Anyone have any doubts in this? Good, Channa, you are right. It's 20 volts only. Anyone has any doubts? Think no comments. So, in closing this session, these videos available at YouTube with the channel name is Basic Electrical Circuit, and the following is the link. And thank you. Today we are going to end up this session. Thank you everyone.